Hello.
Oh. Hi, Sachin.
Hey.
Where do all these windows come from? I was just working for a day. Now I have 50 windows I have to close.
Hey. Hello. Did I miss any conversations about haircuts?
Here AI campaign. Delete this line.
Hi guys.
We don't want to mention anything about haircuts in the
Yeah.
Except every time we say haircut, it's going to keep putting haircuts into the AI summary notes.
Yep.
If we say it too many times, it thinks the meeting is about this and emphasizes.
I get the
Shall
feeling
we
that
accept it?
when yeah, exactly. This will be this will now be the joke that we have for the next 5 months, and then in the at GraphQL when we have the panel, everyone wonders why we only talk about haircuts. Just watch the recording, guys. Some inside jokes.
Yep.
Let me just quickly check. 1, 2, 6, 7. Okay. Seems we are complete. So let's start. Okay, Pascal, are you sharing?
Well, apparently you are sharing now.
Yeah, okay. Good. Okay.
I mean, I have the spectra ready here.
Don't worry.
I've added a pull request
Yeah.
for an agenda item.
Let me quickly check. Oh, you added one, and I dropped it. Is that what happened?
Well, I did that anyway. Doesn't matter. There's only one topic
Okay.
today. It's satisfiability.
It's on
Okay,
there. It's on number 4.
Ah, it is.
there.
It's in the middle, yeah, that's why it's confusing, because it's review agenda after spec.
Yeah, I messed it up because I when I merged it, Pascal and I created the pull request at the same time, and then okay. Anyway, let's start with the meeting, and let me first remind you that by being here, we all agree to the GraphQL spec membership agreement and to the GraphQL Foundation Code of Conduct. You can read up on all the agreements right here in the agenda if you need a refresher. Otherwise, we have first our introduction, and we do it in the order of the agenda. That's why I share actually my screen. I'm Michael, and I'm the host today.
I'm Martin. I'm with Apollo.
Hi, I'm Sachin with Apollo.
Derek with a poll as well.
Pascal, chili cream.
Shane with Apollo.
Coming from the guild.
Okay, awesome. We just have one agenda item because Pascal created a pull request with an initial version. It's really meant as an initial draft for satisfiability, and I give it away to Pascal.
Okay. Did anyone read through it again? Read through it, or should we go through the pull request quickly? Then we can have a discussion about it.
Yes, let's do that anyway. It's good.
Okay. Yeah. So expect the AI companion to write down every word I say now, one to one. No, please don't. Okay. So we have the validate satisfiability section. And essentially, this is just an introduction about what satisfiability is. That we merge many source schema into one, and we need to make sure that actually all fields or all possible paths are resolvable. That's also where Shane, your rule come in, that any valid graphical operation, query mutation subscription, that the composite schema accepts will not fail to requested field being resolvable. Essentially, all possible paths have to be resolvable. Then there's a quick example. Let me open the comments so I can see what you type. You can also just scream at me. Yeah, and this is a small example without any details. There's big examples at the end which we can go through, and maybe you have better ideas on what we can actually add for examples. So it all starts with the definition of a path, and a path is a sequence of field selections through the composite schema, starting from the root operations such as query, and continuing until reaching a leaf field, either scalar or enum, and the path will be expressed as this. It's essentially the query path that we had before, but it just uses the field selection path syntax, which is in Appendix A, because it's a bit more compact than to have all the fragments, the inline fragments.
It looks quite ugly, I have to say, but with all the generics that we have there.
I take that personal. No, I'm just kidding. Yeah, so quick introduction to how this works, but it's quite clear. So you're in the type query. The query selects field A, which returns B, then B returns C, and then we are in the field C, which is a scalar value. This could also be actually made in a proper example, so that it's not ABC, but I don't know, user, email, whatever. Okay, then that's a bit it's very much the input that Sachin gave last week, that at each step, or 2 weeks ago, that each step in the path we compute a set of source schema that can fulfill the specific field selection. Essentially, what we track is we track the possible options that we have in the current position of this path. So for example, we can navigate, we are currently in users, but we can also be in this path in profile. Exactly. And if at any point along the path the option set is empty, it means that no source schema is able to resolve that field. In such case, the path is considered unsatisfiable. So if we don't have any options, we failed. Then visited states for loop detection. That's also a bit the input that we received last week or the week before. It's that since composite types can reference themselves or any or another cyclically, it's essentially detect when a state has already been visited to avoid infinite recursion, because infinity is pretty long and we don't want that. And then the state that we have to track is essentially an option set, which means is a set of source schemas that are currently able to resolve the path. And the type, that's actually not quite true, but different topic. And the type is the composite schema type. So this would be user product review. And then we essentially have a set of schemas, like user profile, which this type was already visited. Then we already go into the formal specification. So the satisfiability check determines whether every path in the composite schema can be resolved by at least one source schema. In particular, plan options, which is the mysterious method algorithm that we haven't defined, needs the exact path as an input to figure out which source schema can handle that field at each step. And then what we do is we begin from the root, and we construct the initial path, which is query, mutation, or subscription. And then we start exploring these paths. So we ask plan options, we'll see it in the algorithm below. We ask plan options while we are visiting this path for the options, and then store the state on this set that we have. If the resulting set of source schemas, the option set, is ever empty, no source schema can be resolved that field under the current path, and the schema is immediately deemed unsatisfiable. If the field is a leaf field, scalar or enum, the exploration of for the path ends successfully. If it's an object interface union, we enqueue a new work item within with the path and the updated option set. The loop detection relies on type option set. Once we revisit the same composite type with the same or larger option set, we do not expand again, ensuring we never loop infinitely. Is that correct?
Yeah, that sounds right to me.
Okay. Okay, good. So now to the algorithm. It's actually fairly simple. I have no idea if it's correct, but let roots be the set of root operation types in the schema. So that would be query, mutation, and so on. Now, for each of these roots, we let the initial path be the path consisting solely of the root represented as root. This could be query, it could be mutation, it could be subscription. Then let initial options be plan options initial path. Oh no, that's not what I wanted. Yeah. Plan options initial path. Then if initial option is empty, the schema is unsatisfiable. We don't have any option to do anything. Shouldn't happen, but just for completeness. Then let Q be an empty list, and let visited states be an empty list, an empty set of tuples type option set. Now, we enqueue the tuple root, initial path, and initial options into Q. And then while the queue is not empty, and this is essentially the whole satisfiability, we now do this. We dequeue the tuple, then we check if the current type and the current option is already in visited states, and continue to the next tuple in the queue. And if this is not the case, we add the current tuple to the visited states. Then we get all the fields of the current type, and we iterate over all fields of this type. Then we say the return type, let the return type be the return type of field, and then we get all possible types of this return type. So if it's an interface, a union, this matters if it's an interface or a union, but with object types, there's just one possible type anyway. Now, for each possible type, we let the new path be the current path extended by field with possible type. So for example, we have the current path, then we add the field name, and we add the possible type. Let new options be the plan options new path. So we take the new path that we just discovered, and we give it to plan options, and we say plan away, and we get back a list of possible options where we, in what states, on what subgraphs, and what source schemas we can be. Now, if new options is empty, the schema is unsatisfiable and composition fails. If the field returns a scalar or enum, a leaf type, continue to the next possible type, because we have to do it for all of the possible types. Otherwise, enqueue the tuple possible type, new path, new options into queue. And if this goes through, then your schema is satisfiable. Does that make sense?
Yeah, that's on a high level. Yeah, that sounds about right to me.
Yeah, the second step under the iteration where you say if current type current options is in visited state, the is in is kind of that's doing the supersetting, right? Or that's checking for the same or superset, right? Is that the
Where are you?
Well, it says if current type comma current options is in visited states, continue to the next tuple in the queue.
Yes.
Presumably that's implementing like the whole if you visited the state before, then you don't have to actually continue with that state because it'll just be recursing, right? Is that right?
Yeah.
So
Yeah.
I'm just saying in that case, when you say it's in visited states, it doesn't actually have to be in the visited states. It just has to be equal to something in visited states or a superset of something in visited states. This is going back
Very
to
good. Very good. You're right. Because it could be this one or more.
yeah, that's
It
right.
could be that if we have in the visited state, we have type user, which is valid and we have already seen this in the profile subgraph and in the user subgraph. Then we don't have to visit it again if we just find type A, which is only available in the user subgraph because we have it already. That's correct. Which makes this incorrect.
It's autocorrection. This does not seem correct. Very good, ChatGPT.
Yeah, so that needs to be fixed. Yeah.
Yeah. Also, just do comments on the pull request. Like, I think this is a very rough initial draft. I think especially the preamble, we might want to add a bit more.
Yeah. So now follows.
I guess real quick, this is a little bit nitpicky, and this I guess is the
It's
maybe
also
an
for
optimization. But the sorry, go ahead.
there's another thing before I forget. So when you say when you have already visited this type with a superset of current options, it's specifically you want to check if you visited this type already with a subset of whatever your current options is. Sorry. Well, maybe it's current options is overloaded. Or sorry, no, it's not overloaded. It should be
yeah,
subset.
With a subset of current. No, where we have already visited this type with a superset of current.
So
No.
if there's something in if we've reached this point in time and we've the number of options we have is strictly more than a previous visit, then there's no point in keeping on going because we've already validated we can do it with less options. So does that make sense? Like what we're checking is if the thing in the previous visits is a subset of what we currently have for our options. Like if we have strictly more options coming into it, then it doesn't make sense to continue iterating because we know we'll be able to satisfy it. Because we
Yeah,
did
so
so with less options before.
you visited a type of A and B, right? And then you get back to this type of A, B, and C. So you already know that A and B is valid. So, right?
So when we have these, when we have this state, A is valid in user and profile, and we enter this if and we have A just in user, then we can stop.
That's right. If visitor states has a user in it, then that means we can stop.
Right.
No, but
We can-
I think you're you're talking past each other, if I'm correct. So we're saying a user is in the visited states and the current state is a user profile, right? But I think Pascal was saying the opposite.
Yeah, so I said that A is the current type.
Can you add
No, no.
which is the visited type,
Yeah,
visited state, and what is the current?
Yeah, there's current options, which describe essentially what you just popped off the queue, and then there's also visited the visited states thing, which describes like what you visited before. So which one
Yeah.
of those is maybe the clarification just for the example?
So
And
vid-
I think we need to
visited-
remove the pro in the second one, the second line.
So this is visited states. And this is current options. Current options is just user.
Okay, if that is the case, then you would have to keep iterating. You would not be able to you wouldn't be able to break the loop.
Right.
Because in that case, you have strictly less options than you had before, and it's possible when you have less options, if you keep going, you actually find that you have something unsatisfiable. If you inverted that example, so visited states had user and your current options had user profile, then you would be able to early return there, or you
Yeah,
wouldn't have
because
to stop iterating.
we already know that on A we can resolve the whole user. But that's not a problem.
Yeah.
That's right.
Yeah, so it needs to be a subset.
Yeah, that's true. This is where we have already visited this type with subset of current options. Good catch. Very good. Makes sense. Any other?
If you scroll down to line 6213,
Sorry.
I guess, or whatever.
621.
Keep going down. It's in the as we're iterating over all the possible types.
621.
Yeah, the 6214. We say if the field returns a scalar, then we can actually just go to the next possible type.
Okay, good.
We probably
Possible.
just or a field, one or the other, but we can probably move that up to the first thing we do on 6209 because we don't want to do a plain options if it's a scalar.
Well,
It's an
if
optimization, but
I think we still need to plan options for a scalar, right?
we can actually do we need to plan options for a scalar, but what we can do is if we can actually say if possible type is a scalar or an enum, continue to the next field. Because we just did we planned.
I think that's a weird use of possible type, because possible type is usually used for object types only.
Yeah.
I know.
That's what I'm saying.
But
Like it should go first. Like
Yeah.
it
if
was
it,
so
So
it was so
I think it should be after 6207. It's like if return type is a scalar or an enum, and then
yeah, that doesn't yeah. Yes, you're right. But then we have an if else. We
yeah,
have an
but
if.
yeah, but then yeah, Martin, you're
or
right.
or an early
We still need
exit.
to
Yeah.
We don't need we still need to plan it so you don't return. So really, you can just remove. You can probably remove that line altogether, right? Because like in your example here, a possible type could be a scalar, and so if it's a scalar, and that means there's only one possible type. So we're only going to loop once, and we create a path,
Yeah,
plan it.
but
and
it's correct. It's a weird usage of possible types because possible types usually is Michael, correct me if I'm wrong, but
Yeah,
it's
it's
usually
associated with abstract types where you ask for the
Composite
possible
type.
types of the abstract types.
But you can also ask for possible types of all composite types, right? Also, you can ask the possible type of an object type is just the object type itself.
Yeah, that's correct. That's correct. That's also how we do it in the spec. If you pass in an object type,
Can you
to
also
ask for
do,
the
can you also do it on a scalar?
I don't think it's ever
No.
used that way.
Yeah, I don't think
then-
we can really use possible
Then
types.
let's switch it.
Okay, then we
If
need to define it. Okay.
Otherwise, so then let's move this here. Because now the path is also different, right? Because the path is not with the possible type, it's just with the field name. So that actually
Yep.
makes sense.
Yep.
Let new path be the current path extend by field, and then
Yep.
we continue to.
Yeah, I think on
Need
on, on 6.2.10, like possible type needs to be removed. Like it's not extended with possible type, right? Yeah.
Yeah, good catch. Okay. Yeah, makes sense.
All
Otherwise,
right.
very
Well.
complex.
ChatGPT, write an implementation of this algorithm. Yeah.
Well, ChatGPT, the first question will be of ChatGPT. Please provide me a definition of plan options. Because
Yeah.
that's all we need to do next. Yeah. But I have here, there's a whole I don't know, nearly a case study about what satisfiability errors can occur. And I had big trouble in deciding what to put in here and what not, because they're all very similar. They all lead to the schema is not unsatisfiable. So I included examples for things which are slightly different, which can be caused by slightly different things. For example, in the first example, it's extending a type with no lookup. So we merge together user, but user is not an entity because user doesn't have a lookup, neither a key. Therefore, it explains it here a bit what the problem is. And then I have another case where the composite key field missing in the second schema. So we have a lookup product by ID, and we have a lookup product by ID SKU, which is the ID and the SKU. And then it explains that while you can jump from this side to this side, you cannot jump from this. While you can jump from this side to here, you cannot jump from here to here. And there I also use the same path syntax where I say plan options with query product by SKU name, right? Stock. Just found an issue.
By
Plan
the way,
option-
yeah, go ahead.
Plan options with query product by SKU product.sku would return an empty set, because essentially you're here, you are in here, you're in this product. Now you want to plan SKU and you cannot. No, it's the other way around. Sorry.
Yeah.
No, yeah, it's the other way around. Your query product by ID, you're in here on the name field, and then you cannot go over transition to
Yeah,
to
it
the
should be
other.
product by ID that name. Right?
Yeah, yeah, the SKU is wrong here. So that's
Yeah, I've created with Glenn, by the way, a couple of these test cases, Pascal. As he was
Yeah.
implementing, and he asked about a lot of test
Yeah,
cases,
if you
and we
if you
started.
find something which is a different flavor of satisfiability, or just add it as a comment, and then we can add specification for it. I have like five. I have five.
What we anyway should do in the when we start on the test cases for validating spec implementations, right? We should have these test cases and also explain why they fail. Like we looked, for instance, at the test suite that we have at the moment for federation solutions. And they have a lot of tests, but there's also what's missing is like really an explanation why these things fail for a new implementer, right? This is not bad how you did it there.
Yeah.
Just going back up to the first one. The first one isn't a satisfiability error, it's a composition error. Or just a invalid schema, right?
The first
Why?
one.
Wait, sorry. Are we not doing keys for the examples?
I believe we went with option 3.8.
Yeah. So it could just be It could but just be, but it still needs directives, right?
You are right. You are right. So this would at least need to be shareable to be not a composition error.
How about there's so like maybe in that example there's a third schema that does have a lookup and that is actually a entity there.
Wait. You don't take it away. We're getting there. So the next one is a key mismatch between source schemas. Essentially, this where you have a lookup. Now key directives are missing again. So yes, I need to either make them shareable or add a key. But here, the product by ID, and here we have product by SKU. So this is not satisfiable because you have this path which will end up with an empty set of options. But now to Derek's case, if you have a third schema, which is called the product index, which combines these two, then this is not a counterexample. This is now an example that actually works. Then you can plan options because you can do these jumps between the different graphs.
I don't know how detailed, because like a lot of these satisfiability errors also come with requires. When you have requires in the key, and then you cannot solve the requirement in a specific pass.
Yes, so I had one question about require. I left require out at the moment because require doesn't really add much complexity. I mean, it's the same with require. Like the problem in require is that you have mismatched keys. You just require something and you can transition there because you have mismatched keys. We could add examples for it, but it's just that you have to specifically go to this graph and then you miss the key for this graph. And
Yes,
there's no-
in the end, it turns always out you cannot get this information because you have no way to get this information at this point.
Exactly.
So
Yeah,
there is.
that's satisfiability. So when I wrote these examples, I was like, well, didn't I already cover this? So it's really hard to decide what actually is worth its own example and what not, because it's one error in the end. You did stupid things. Fix it.
I think it's worth keeping this example here because this is showing that fundamental thing that is not necessarily intuitive by just looking at the schemas, that at runtime what we're checking is like you could form a query plan that could go like a whole roundabout way that wouldn't you necessarily like, isn't necessarily efficient, but as long as there's one path that gets there, if you're doing this jumps, that's still valid and we're still good. That's really what we're trying to show off here and like explain. And so what directives allow you to get around and find some path is fine. But I think maybe it's even worth like putting that as an explainer. Like what we're showing off here is like the fact that in the end where there's some obtruse path that still gets you to the point that even if it's just one, it's still valid.
Yeah. Yeah, I believe a require example in the same shape, like having it not working and then making it work would be great. Like you can make this work if you add this lookup and then it works.
And the require example is really also about that, right? Because it's not it's not clear
I thought about
that it does these jumps.
I thought a bit about what from a user perspective, how you can run into these satisfiability errors. And this is one that you don't have enough keys. The other one, what I see user run into is, I will show below, is when you start, when you don't have a common naming and you start mixing the purpose of a type. But yeah, anyway, this one is also common because it looks like, if you look at this, you have the feeling like it should work. Because you have the ID on both sides and you have a lookup by ID and whatever, but actually it doesn't, because you need to go from here to here, you need SKU. And you can also fix this if you add the stock here, then it would also work, but that's not the point. Anyway, so now this is, I had a bit of issues with this because, correct me if I'm wrong, in FED1 there's something called a value type. And in Fed2,
Yes.
there is nothing, there is no longer a value type, but the concept of it essentially still exists. It's a non-entity type, right?
Yeah, it's
And
shareable. Yeah.
exactly. And this is what this explains, right? You have an address in one subgraph, in one source schema, and you have an address in the other source schema, and they're not the same. So you cannot make this work.
But this is a composition error. Again, we catch this before satisfiability.
Do we?
Yeah, because shareable.
Lack of
Yeah,
shareable,
because
you
Yeah.
it's all with that. I forgot the keys of the shareable. So the thing is that, I mean, let's. Oh no! Now Glenn is in the way. Thanks, Glenn. No. He does God's work with reviewing this pull request. I'm so happy. Okay, so where was it? This one.
Command F for address. Yeah, there you
It would need to be something like this, right? Now it wouldn't be a composition error.
go. It still would be, because you have two types that don't match up.
Yes, but that's not a composition error.
Yeah, that's not a composition error. That's a satisfiability
That's
error.
a viability error.
Yeah. It used to be a validation error in Fed1, but yeah,
That's
no
right.
longer is.
Right. I guess if you don't mark them as shareable explicitly.
Well, we don't
Yes.
mark types as shareable. We only mark fields as shareable, because it's just a shortcut to mark all the fields as shareable. So yeah.
That's right. In Fed2, when you mark a type as shareable, all it does is mark the fields that are under it, and that particular type extension is shareable.
I mean, we could just make this.
Yeah.
Because that's probably a more realistic case where you run into the decomposition error. Because you have an address which is used in multiple places. Now you want to introduce, you have a new version of this value type from some central value type library, whatever, you name it. And then you run into the problem that the country is only on one source schema, it's new, and then you get into the satisfiability issue. The only way to work around this is to say that this is internal, inaccessible.
Yeah, in Fed2, you
Internal?
can mark it accessible, and that would prevent it being.
Yeah, that would prevent the issue.
Yeah.
By the way,
Another solution that I remember we discussed at the time was the ability to specify a default value for a field. So for instance, you could say country is nullable, and by default it's null. So if
yeah, I think, to be honest, adding a default value would be a really nice addition, but that's something that has to be. We can add the default value, and then everyone will start using it, and then you will see it abused, where you just have types which half of the type is only default values because the teams didn't care to actually wire up the fields.
that might be one of the reasons we never actually introduced it. But I remember, I think Stephen was there. Like
Yeah, I
we
remember
did
that.
discuss that. Yeah.
Yeah, it could be really useful, but also it can be abused.
Yeah. I would say this is really open, what we do with this. The last example I have here is something which is a bit, again, it will not compose because of the shareable stuff. But it would be, on one side it's an entity, on the other side it's a value type. And this is not something that can really happen if you do good schema design. But if you have teams which don't really care about naming things, then you can run quickly into this issue. Again, it's very similar to the one above, right?
Wait, Pascal, can you stay on there? So what's the problem here? The category is a
On one side it's an entity, on the other side it isn't. So you're missing the lookups. You have no way to get the name of the category.
okay.
It could
Now I
happen,
see.
that these guys, let's say, again, this only really makes sense if you have a shared type across at least 3 schemas. When you have a value type which is shareable, which is not in this example, but which would be shareable in 2 schemas, and then someone thinks it's a great idea to add a lookup for a category, and then you run into exactly the issue, or you run into the issue that on one side it's actually a lookup, on the other side it isn't a lookup, and then you can't go through, you can't cross the borders. It's the same everywhere. It's just different ways how you can run into the same problem.
And
This
would
is
that also
actually,
be a composition error though before we get satisfiability?
Yeah, you would have to do it like this. Hi, Glenn. You have to do it like this. And here you would have key. Actually, here we wouldn't even have that. That wouldn't be a composition error because we would just merge the types. It would just work. It's a satisfiability issue. We don't even need shareable in this case.
What? But you need key on 6488.
I mean, we can just.
So the keys are, I think, as you said, they are optional because they can be derived. But I think this is actually an interesting case, though, because it actually shows the difference between the Apollo Federation and this one. Because in Apollo Federation, when you mark something with @key, it gives you that like implicit entities resolver that we can actually resolve it by that, right? And the other one, now we need explicit lookups to actually do those, right? So technically, like if you have a category and there's actually a key there, but there's no way to actually resolve it there, that's an interesting case.
Yeah, it's
Well, on
it's observable now in the schema. Like if the entry point, like in Apollo Federation, it could be a runtime error because you don't have the reference resolver. But here, this fact is now observable in the schema.
Mhm.
So if type category in the first schema had ID, and let's say has description too, just I
Yeah.
don't know.
Well, even you just you can make an entity and just you don't have
but
the
no lookup. But if it has no
Yeah.
lookup,
Yeah.
Yep.
so it's not really
Then
an
you
entity.
but
That's
then you
good.
could go in one direction.
Yeah.
Like you could go from the first graph to the second one, but not the other way around. So
Yep.
depending on
It's,
So
what other fields you've added.
would that be
so-
valid for it to not have a lookup?
Yes, because what you can do is this. Now it's completely valid. Because the fields that you have are actually part of a key and you can resolve description. The problem is this name that you added here. If you have this, then you're good again. You don't have to worry.
Also,
It doesn't need to be part of the key. It's just that there needs to be all of your fields need to be resolvable by the combination of your, I mean, now it's not, now it collides again. Sorry, Shane. If this is shareable, of course, then yes. Now this would work theoretically.
I think on line 6.4 and 9.2, you still need to mark name as shareable as well. Just to nitpick.
Yeah. Yeah, I was like, yeah.
Well,
When
let's
I
say
gave-
we if we only had the key field on there, so we only have ID, but we don't have a lookup, we don't mark it as a key or anything. It's just still, because we were saying we can infer keys, but do we infer the keys on a subgraph that doesn't have a lookup?
No.
No.
Yeah.
And that- yeah. That would
It's
be
also
something.
it's also just to be very clear here. If you don't have a key directive there, then it must be shareable if you have it on the other type. Otherwise, it's a composition error because these field collides. It's just that Pascal wrote these examples just to show his problem without making it a fully valid source schema here, right?
And now everything is shareable. No, I'm
Yep.
kidding.
I think we can keep going forever on good examples to come up with.
Yeah, we need to clean them up because this is exactly where people would stumble over.
Yeah, so big question. the elephant in the room. What do we do with plan options? Because what do we need to be able to specify what plan options does?
It's roughly the same or loose algorithm like this, right? You get a path and you say, you know, explore the schemas, the source schemas that you have, and iteratively figure out a way to get there. And so like we just need to describe like the fact that you go look at all the source schemas and you would start. I don't want to describe the algorithm because I'm not very good at it, but I don't even know actually how do we start to, if we start at the end path when we do it in Federation, or if we start at the root, but like
I mean,
you
you
can
have
just
to talk about the root, right?
We start at the root, right? So
okay.
Yeah.
basically this is the option generation step of query planning in our case for Apollo Federation. In some sense, right? But the gist basically is you try to consider all the possible ways you can essentially take that path through your subgraphs, and you really just care about the endpoints at the end of the day. But that's kind of what plan options is about doing. Is essentially it's saying for each element I figure out where we're given where I previously was and what options I had for the previous step. Like, well, what can I take for the next step? So basically include things like subgraph jumps, and you include things like fields you can take along the way, and you'll that's sort of the idea behind it, at least.
Yeah. But those are all things we still need to specify because we haven't really specified yet what the equivalent of a query graph looks like and what kind of traversals we need to define.
Yeah, so if we wanted to keep it not simple for now, we should at least specify that you should find the appropriate collection of subgraph queries that could resolve this this path. I guess, but we're missing is all the details of like what is a subgraph jump, like, and like what is like things that I should be aware of and how the subgraphs connect. And
that's the point. I mean, thinking about this, we should probably cover parts of the execution first before we go into plan options, because we may or may not be able to reuse parts of the execution for it. Like if you need to know, you have now a actually, we need to talk about execution just in general. Like, how do we want to describe execution in the spec? Do we want to describe execution in the spec based on a query graph where we explain that we compute the query graph and then we execute it, a query plan and then we execute it? Or do we want to describe it more like we did it here with the root, with the public API schema, with the composed schema? We just describe it on a query basis, where we do actively on the query, we try to figure out what the options are and where to go. Because again, we don't really have to care about execution performance here. So we don't necessarily need to compute a query plan that we then execute, which is a great optimization, but it's an optimization. We can really just say the user has selected this field set. Now, how do we execute it? And then we can go for each field and figure out what to do if this works. Or
I mean, in that sense, this plan options and query plan is the same, and all you're doing in a query plan is doing plan options on every single field on the user's query, every single scalar field, basically. Like,
yeah, it's a bit. The question is how far we want to go with execution, right? Because
I think we should just do that. Like, I don't think we should worry about trying to specify like the fact that the query planner doesn't like, try to calculate a query plan for every single field that you calculate. We traverse the graph trying to figure out as we're selecting them. But like in the most basic terms, plan options for a single path is doing a query plan for that path. Like find the plan that would make that viable. And so if we have that specified, we can say in simplest terms, if you wanted to build your own query planner, which says here's a query which selects a bunch of fields, all you actually technically have to do is run plan options on every single field selected,
But that's
which is
not
not
true.
efficient, but like that would work.
That's not true, because you can make sure with the satisfiability that all of the paths are executable, but it's not necessarily the case that so when you have two options, you have to choose, because sometimes you have to choose, because the only thing that you say is that it's there's 100% you covered 100% of the cases where your whole schema is covered. You can execute your whole schema, but you still need to decide where to fetch the data from.
Well,
Like
that's
if
what I'm
you
saying.
have-
That's an optimization. That's like the fact that you should decide which to choose, which is better, is like an implementation detail. Like it shouldn't be relevant. Like if in theory, I know this will be terrible. Let's say like plan options gives you, hey, there is at least one valid query plan for this path, right? That's essentially what it says. And then you say, okay, that's what we're doing for every field, but I'm gonna write a user operation, a query, a real query, which actually selects the user, and I want the user's email, name, and then the address, and address has the street, the city, etc. So like, here's a query with a bunch of fields. In theory, if we ran the algorithm plan options against it, you would get 10 entirely different query plans that would like all refetch from the same subgraphs over and over again. It's a very bad query plan, but technically it's valid, right? Like the router in theory could go execute that one query plan for the first field, another query plan for the second field, another query plan for the third field. It's terrible, but like it's technically valid. And that's what I'm saying. Like we could just leave it there and say it's implementation detail for you to figure it out.
Not when you talk about lists.
Lists? How do you mean?
Well, when you fetch a list, you cannot.
Oh yeah, I know what you mean.
When you fetch an element from a list of a list, you cannot point to this field directly. Like you would get a tree with list items in it. Like let's say you have users at users friends name and age. Now you would first fetch user friend's name, and then you would fetch user friend's age, and then you have two completely different trees of results, because you have users, which is a list, then you have in the list objects with friends, which is a list, and then you have objects with, I mean, yeah, you could say, and then merge the JSONs. merge the JSONs and be done with it.
I mean, yes and yeah. Yes,
Also,
like we shouldn't do that in implementation, but like if it's just looking at the schema, in theory, if you run the same query, user's friend's name, and you pass in the same arguments and you run user's friend's email, you should, in theory, get back the same, assuming the APIs are the same, or you pass in the same arguments.
And assuming the
should get the
data
same
hasn't
data.
changed in between.
Yeah.
Like the list is stable.
we just use distributed logs, then the problem is solved.
Yeah.
You know.
No, but
This is one of
technically,
the
yes, you could also say make the query plans and then merge. I mean, merge the queries that you produced in the query plans would also work.
When you merge the queries, what comes out again?
No, but what Pascal, what I mean, you can merge queries. That's also what we do in part in our query planning, right?
Yeah.
Where we find out, okay, these queries can be merged to reduce the network overhead. That's actually what you could do. But I don't know if it's so nice to read in the end, the algorithm.
So
let's see how much progress we can make on this, and then we could use it as an escape hatch if we are not happy with what comes out.
So now let's put it this way: I now know that I can fetch this field from a subgraph, but I still don't know how, because there might be two hops that I have to do in between. There's subqueries that I have to do. There might be a requirement which I have to resolve. And just from the output of plan options, this doesn't help me much, right? Like, I know that now there's a path to this field, but I have no idea how to get there.
Yeah, there are lots of details that you have to in the query planning, like also about ordering and inlining and stuff like that. But it's also, we have to think about what of these things we have to specify.
Yeah.
So, but we still have to specify plan options, right? Before we can move in any direction.
Well, there's much that you will get there, because you can reuse a lot of this from the execution. Like if you need to resolve a requirement, that's what you need to do in the execution anyway. So you can use this to check if there is a requirement.
We are also in 3 minutes at the end. It would be great if everybody goes over this. I think Pascal, if you check in later the latest tidbits, then if everybody annotates on the pull request, then we can see that we get the version in of that. Then we are quite a bit further with the spec text.
It would be good if all of you, or the ones that will join next week, could think about what we want to do with execution. Because if we all make up our minds what we expect the spec to have for execution and in what level of detail, we either specify plan options now and then just write execute the query and you're good. Or we write the execution first and then reuse the bits that we have in the execution for the plan options. I mean, I have to say, I'm quite happy with what came out of satisfiability, because 3 weeks ago or 4 weeks ago, we talked about satisfiability and we had no idea how we were able to specify it. And now after we talked about it and slept 30 times over it, we actually have an algorithm which is pretty simple, which isn't not really efficient, but that doesn't matter. Okay, cool.
Awesome. Then let's finish here and let's talk next week again.
Yeah, sounds good.
Goodbye, everyone.
Bye-bye.
Thanks, y'all.